Good morning, good morning. Yesterday we did sine, cosine from ARD to the curves and domain range. Do you guys have any questions? I definitely have assigned you some homework, so please do it. That would help you to understand the lectures. And are there any questions? Okay, if you don't have any questions now, which you know that you can ask questions anytime, I would like to continue, right? So let's recap what we did yesterday. Sine, cosine as two functions. The inputs are angles, and they can be any angle, radians, degrees. But for the curve, it's radians ratio. Okay, so after class yesterday, I reconstructed the I did the picture to demonstrate that these blue numbers corresponds to the blue bars, and these red numbers corresponds to the red bars. The orange are the arc length, Okay, I hope that helps. The only thing I'm not able to do easily is to mark the orange arc length, which is here. Okay, and I think I'm gonna figure out a way to do it, but before I can get that done, you just have to make sure you understand the lecture. Okay, you just have to make sure you understand the lecture. And let's go back to the definition. Let's see what else can be digged out from the definition, right? What else can be digged out from the definition? So I'm going to bring the definition over to the top, right? We have the definition here, okay? And in this case, okay, so let me just save it to today's 28th. All right, definition, right? So here's the definition provided ARD, okay? So definition is based on this, we set the stage. I've been repeating this, right? ARD, right? A is for angle measurement, which is referring to the angle as input to the measurement, right? R, okay, D, okay? And we're gonna study the rest of the functions in terms of, domain and range. But before that, we said yesterday, we haven't done the intercepts, right? We haven't done the intercept for these functions. So maybe we can get the intercepts, right? Shall we? What does the intercept means? What does the intercept means? What's x-intercept? What's y-intercept? Take sine, for example. Take sine, for example, right? The input is A, right? The output is sine of A. It's a ratio. We know it's a ratio. When we talk about x-intercept, y-intercept, what is x-intercept? What's y-intercept in terms of input output? In terms of input output. Okay, for example, y-intercept. What is y-intercept in our current situation? Y-intercept refers to when the input is 0, right? When input is 0, what will be the output? Right? X-intercept refers to what? What does x-intercept refers to? X-intercept refers to that the output is 0. Find all possible input. You guys see the difference? Do you? So as a result, by definition of function, each input will have exactly one output. So for input 0, what is the output for sine? Obviously it's 0, right? You can observe this from the curve we graphed yesterday, and you can also observe this from the unit circle. Because when the angle is 0, the terminal overlap with the standard position. So in that case, 0, the blue number 0 is for sine of 0. So the x-intercept, the y-intercept is 0, 0. Okay. How do we find the y-intercept? So what are the input that will cause the output equal 0? How many? In the y-intercept case, right, input is 0. The output is exactly 1. So there's only one and only one y-intercept. How about x-intercept? How many x-intercepts are there? Where do we look for them? How do we find them? Let's see the chat message. Good morning. Okay. So how do we find the x-intercept? X-intercept means the output is 0. Input is to be found. So how many input are there that will cause the output equal 0? Okay, so let me rephrase the question. Okay, I'm going to copy this piece. I'm going to put it on the top. Or maybe put on the bottom. We want to identify, okay, so to find x-intercept, maybe plural. Is that okay to have plural? Does that violate the definitional function? No, it doesn't. It's just for multiple input, their output is 0. That's okay, because for each one of those input, the output is still unique. That unique output is 0. Okay. To find x-intercept, the question is if, okay, that is, if the output is 0, sine of A is 0, find all possible A's in the domain. Of course, the domain for sine is all real numbers, right? There are two ways to do this. One way is to take the curve, recall, how did we find those x-intercept before? How do we find x-intercept before for the other functions? Right? So suppose we know that sine function is a periodic function, that we can show more pieces, right? -10 to +10, for example. Right? Where do we see x-intercepts? Where do we see x-intercepts? Where do we see x-intercepts? There's one here. There's one here. There's one here. There's one here. 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 That's where the curve crosses x-axis, right? What do all these points have in common? On this point, the input is unknown. Of course, we can find out the output is 0. On this point, the input is unknown. The output is 0. The input is unknown. Output is 0. On this point, do you guys hear what I'm saying?
Yes.
Don't x-intercept have the same meaning for any function? X-intercept has the same meaning for any functions. It doesn't matter. For all the function we had before, quadratic, you know, all the function we have seen in that basic table and all the function you have seen in the past, the polynomials and all of that stuff, x-intercept always have the same meaning. Input is unknown, output is 0. So our job is to identify, what do we identify? So from this picture, you can tell there are infinite number of them because the curve will go on and on in both directions forever, right? So that's determined. We have an infinite number of them. But what are these inputs that will make the output equal 0? And here, this one we know is when input is 0, the output is 0. So we already have one. How about another one? How about these? Well, let's look at the unit circle. Let's look at the unit circle. Okay. Where on this unit circle, we know the blue numbers are the outputs for sine, right? For the different angles terminates at those with terminals at all these, you know, on all these terminals. Now, which one gave us 0? Blue 0. Where do you see blue 0? Where do you see blue 0? How many? How many blue zeros do you see? Those are the output equals 0, right? Hello, are you guys there?
Yeah.
How many blue zeros do you see on that unit circle?
2.
2. What does that mean? There are 2 terminals, right? Terminal 1, terminal 2. Any angle that terminates on either one terminal, those angles will make the output equal 0, right? Do you guys see that?
Yes.
So this question is what? When we talk about ARD, is from D, okay? D is definition, D to A. Instead of from A to D, this is D to A. Why D to A? Why D to A? Why D to A? Because we know the sign of A equals 0. This is definition. So we know this piece. We know D to A, we know D. And we find the bridge. The bridge is reference angle, right? These two are reference angle, you know, they're terminals. They also make the reference angles. Reference angle is 0, but they're not a strictly reference angle in a way, because reference angle has to be positive acute, right? Has to be positive acute. Excuse me. right? So we find the terminals, D to A, right? D to A. R is kind of just to find the terminals. So A is the question. Do you guys see the nature of the question? That's what I want you to see. Do you see the nature of the question? At the beginning of the trig review, what did I tell you? All the trig questions you deal with is either from A to D or D to A. No exceptions. No exceptions. At least I haven't seen any. I have not seen them. Okay, I've been through colleges and graduate schools. Haven't seen them. Okay, all the questions, all the trig questions you are going to encounter is either from A to D or D to A. So this is the case of D to A. So once we have identified the terminal, okay, then we get to A. How do we measure A? How is A measured? Well, we know 0 is one of the solution, right? And if we measure pi, sine pi is 0. So this is pi, right? And we keep going. If we measure this 2 pi, this is 2 pi. That's too ugly. That's 2 pi. Right? And how about if you measure clockwise? You measure clockwise. So if you measure clockwise, okay, if we measure clockwise, I'm going to have to clean this. If we measure clockwise, what do we get? We'll get a negative pi. Where's negative pi? Right here. Okay, so this point, negative pi, 0. The output is 0. Do you guys see that? So do we see a pattern? Do we see a pattern? Do we see a pattern? From the curve here or from the unit circle here, do we see a pattern now? So what are the input will cause the output equals 0? Pi, 0 is 1, right? Right? What else? Pi is 1. Plus minus pi, another. Plus minus 2 pi. Plus minus 3 pi. Does the list go on? Does the list go on? Yes?
Yeah.
If that list go on, does that include all possible inputs such that the output includes 0? Have we left anything out? Those will be the x coordinate, will be the input for the x intercepts, right? Right? We should call them input intercept, right? Input intercept, right? So is there an algebraic expression that will express them all? What would that be? Right? So the x-intercept will be 0, 0, right? The proper way to express it, that'll be plus pi minus pi, 0, plus minus 2 pi, 0. These are representing 2 points, and so on and so forth, right? So what will be that algebraic expression that your professors all like and like to see you are able to present to them and give you points? What will be that expression to show all of these points at which the output is 0. That expression is k times pi. K times pi, comma 0, where k is any integer. Okay, so let's mark these points. Right, let's mark these points. So this point is what? What is this point? That point is what?
0, 0 for that one.
0, comma 0. How about this other point?
Pi, 0.
Pi, comma 0. How about this point?
Negative pi, 0.
Very good. And the list go on, right? So this go on. And to express all of them where there are infinite many, that's the expression. That's the expression. K pi, comma 0. K is any integer. Any integer include what? 0 plus 1 minus 1 plus 2 minus 2 plus 3 minus 3. And your calculus teacher would expect an answer like this. Okay. And in this case, right? How do we answer that question? Okay, there's all kind of way, depending on how the question is asked, right? At the top, if you're asked to express the point, and that's how you express the point. But if you say, oh, if the output is 0, find all possible A in the domain, and those A would be what? Those A would be k pi. And k is an integer. Do you guys see the difference? The question is different. Okay, if the question is asked in this way, that's your answer. If the question asks you to give all the x-intercept, and that's your answer. Do you see the difference in the question? Because this one is asking the input, just asking for the input such that the output is 0. In this case, is asking for intercepts. Intercepts is a point. In these points, you're given both input and output as a pair. Therefore, that will be the answer. So depending on how the question is being asked, and we know how to give the answer. Okay. So now what shall we do? We're going to put this answer in the table. Right? So what is x-intercept? Where is it? Did I put in the row? Not yet. Okay. So I'm going to put in the row, 2 rows. Okay. So in the summary table, we have y-intercept. Does everybody follow me? So
Yes.
y-intercept is just what? 0, 0. How about x-intercept? Intercept. We have plural. Okay, that would be k pi, comma 0, where k is any integer. You got it? You got it. Yes?
Yes.
Any questions? Any questions, anybody? Is Farouz here?
Yes, Professor.
Okay, thank you. All right. So now, Let's look at cosine. Okay. What is the x-intercept, y-intercept for cosine? Let's start with y-intercept. What are the y-intercept for cosine? What's the y-intercept for cosine? You can tell from the picture here, right? Once again, y-intercept is the same concept, right? Y-intercept is the same concept. When input is 0, right? When input is 0, where did I put that? I thought I put it somewhere, right? So when input is 0, what is the output? So y-intercept is really what? Is the output intercept. Do you follow me? Is the output intercept. We like to call it y-intercept because it really should be called output intercept. So where does the curve cross the y-axis? Right here, right? Can you tell? 0, 1, right? You guys see that? Is that obvious to you?
Yes.
0, 1. It's right here. It's staring at us. Right? When x is 0, y is 1. Cosine 0 is 1. Right? Cosine 0 is 1. By definition, right? By definition. And then what? How many y-intercept do we have?
Just one.
Just one. That's right. One and only. One and only. One and only. Why? Definition. Right? You see, you have all these reasons to trace back to the very source. Trace back to the very source, which is a definitional function. Definitional function says for each input, there's exactly one output. So for this input 0, you can only have one output. If you have none, then 0 should not be in the domain. If you have more than 1, that's not a function. So you have no choice but having one and only output for each input. Are you guys with me? We haven't been using many concepts. We're really just using the function concept. And I promised you guys at the beginning, the theme of this semester is function. And I've been staying with that theme, haven't I? Yeah.
And these are trigonometric function.
Yeah.
6 of them.
There's 6 of them and there are more. Okay, there are more to come.
Same domain, but different outputs.
Right. And if you look at the unit circle, you guys are all familiar with, right? Cosine is a red number, right? Yes.
Yes.
So which red number give you for the input 0? What output it give you? Input 0, the angle is the input, right? So you measure from where? Standard position, right? You measure 0, so your terminal overlap with the standard position. And so that's A is 0, so the output is red number 1, isn't it? Right, you pick a point on the terminal, and that point you pick is on the unit circle is 1, 0, and you apply the definition, you get 1, right? So that's the whole, process of ARD, so you get 1. Don't forget the basic definition, okay? ARD is super duper important. And of course, we simplify to this point. If anyone has any questions about why we simplify to this point, you should either go back to watch the past lectures or ask me. I know we have some people that in this class haven't taken trigonometry. So you probably have lots of questions, okay? You probably don't want to stay silent if you want to be truly responsible for your own success. Okay? All right. So that's cosine 0 equals to 1. So how about y-intercept? This is y-intercept. How about x-intercepts? How many do we have? X-intercept, how many do we have? Well, you know, this is only part of cosine curve, right? This is only part of cosine curve. If I want to show you the more pieces of cosine curve, and I can totally give you, more. Then you start to realize there are as many points as possible, right? So where are the x-intercepts? Here, there, there, there. Do we have more on both sides? Absolutely, we have many more. How do we find them all? How do we find them all? This is once again is from D to A. From D to A, right? From D to A, ARD, D to A. How do we identify them all? Right, so this is sine. Okay. Hold on. Okay, that's still sine. I'm going to give you the cosine. That's the cosine. Right? So we know these points. How do we identify these points? That's the question, right? They're pretty hard to identify, aren't they? Because they're not exactly on those, they don't fall onto those perfect, whole numbers. So we can use the unit circle. We can use a circle. So when we use a unit circle, how do we identify those? We need to understand the nature of the question, right? The nature of the question is that if cosine A equals 0, if the output is 0, right? If the output is 0, and we want to find all possible A's. Find all possible A's. That's the nature of the question. That's the nature of the question. So y-intercept is from input 0 to get output. X-intercept is from output 0 to get what? To get input. Do you guys see the nature is different? Right? All of intercept questions are the same, exactly the same as I just said in nature. In your calculus classes, you're going to meet the same question, similar question. Your question may be more complicated. The function may be, a composition of 10, 5 functions. It doesn't matter. It doesn't matter. X-intercept is always giving you the output is 0, you identify the input. Y-intercept is always giving you the input is 0, identify the output. Just you remember that, okay? That is a constant, doesn't change. Okay, so we identify. So we want to identify A. So do you guys have a clue how to identify the A? I'm sorry. How to identify the A's? How to identify the A's? You go to the unit circle, what do you look for? You go to the unit circle. What do you look? What do you look for? Tell me what you look for. Anybody want to say something?
You look at the X, or in
look
this,
for the
or in,
X?
or in this case, you look at the red side of it.
You look at the red number. That's right. Which red number will be of your interest? There are all these red numbers, right? The red numbers are ratio of, those are the ratio for cosine of different angles. So which particular number will be of your interest in order to solve this question, solve this problem? We have 0, we have half, we have 1/√2, we have √3/2, we have 1, -1, 0. Which one will be, should be of your interest?
Would pi and 2 pi would be our interest?
Pi to pi. Why pi? Why pi?
Well, because looking at the unit circle, you can see like it's -1,
What
0.
did we do when we do sine? What did we do when we did sine? What did we do when we do sine? In order to identify the x-intercept. What did we do?
We looked at the blue side, right?
We look at the blue 0, didn't we? Did we look for the blue 0, didn't we?
Oh, I see. We should be looking at pi/2 and 3/2, right?
We look for the red 0, don't we? Pi/2, that's right. And what else?
And 3/2.
And go on and on and on, right? How about everybody else? How come we don't have, I don't hear anything from anybody else? Are you guys sleeping there? When we were trying, when we knew the output for sine is 0, when we knew the output for sine is 0, we want to identify all the possible input such that, should I write this down? Do you want me to write this down?
Yes.
I'm kind of concerned about there's the lack of response. The whole point we're doing live lectures is that we have interactions. Otherwise, I can sleep in and you guys just watch the video or watch the recording. Is everybody there?
I'm here.
I know Farouz is there. How about everybody else? Are you with me? Do you understand? So what is the question at hand when we're trying to find x-intercept for sine? Let's do this again. Right? Find the x-intercept. For sine. Right? We know that's the case, that we know the output is 0, we don't know the input. So we're looking for all the possible input, i.e. if sine A is 0, we want to find all the possible input A such that sine of A equals 0, right? So if you look at it from the perspective of ARD, we know D, right? We know D. Why we know D? We know the definition, right? And we want to find A. You guys follow me? I want you guys to see the nature of the question. Nature. You guys understand what's nature? There are only two kinds of questions you need to deal with. You will ever have to deal with in your entire academic career. I don't assume you guys are going to go to graduate school in mathematics. You only have two types of questions: A to D, D to A. And this is D to A. Do you guys see that?
Yes.
Right? This is D to A. So from D to A, so how do you, from D to A? You can find it from the curve here, right? Identify those crossings. You can also use the unit circle because identify the crossings on sign. It's a little bit tricky, right? Because they don't fall on the exact values. It's very difficult to identify. Some of your calculator probably allow you to zoom. But you still have to see the nature of the question, don't you? If you could see the nature of the question, you will be invincible. You will be invincible. You want to be invincible, don't you? You want to be getting points left and right all the time, right? Do you? Then you want to see the nature of the question, don't you? See through it. See through it. That I'm trying to help. That's what I'm trying to help you to do. Then you will ace all the courses. Okay, no problem. Right? So these points, it's difficult to identify, right? But we can look at the unit circle. The unit circle says sine A equals 0, meaning the blue 0. Sine A corresponds to blue 0. So there are two blue zeros. There are two terminals. One terminal is here. And the other terminal is there. And so that's how we identify K pi. Do you guys follow me?
Yes.
So now, for cosine. For cosine, we still want to identify x-intercepts. What do we look for on the unit circle?
We look for the red zeros.
That's what I'm waiting for. Okay. Why red 0? Why red 0? Because these are the terminals where? These are the terminals what? These are the two terminals. There's a terminal here with red 0. This tells you any angle terminates with this terminal whose cosine value is going to be 0. It's going to be 0. And the other one, and we talked about earlier, right? We talked about earlier, you have one terminal, infinite number of angles, right? That terminates there. Do you follow me?
Yes.
Therefore, now we have identified two terminals and two terminals only. Do we have other terminals that give us a red 0? No more, right? Do we have more? Look for it. Do we have more? Do we have more red 0 than these two? Do we have more? Do we have a more terminal other than the two terminals identified that will give you red 0? Has anyone find it? Are you looking?
I want to say that's it for it, right?
I'm sorry?
Is that it? It's just those. It's just those two simple term.
No more. No more. Can you find them? Find them. Let me know. Yeah. That the terminal, other than these two, do we have other terminals?
No.
No more, right? You can have another terminal very close to it, but the cosine of that angle is not going to be 0. It's going to be not 0. Okay? Do you follow me? No matter how close we get to it, as long as it doesn't overlap, it will not be 0. Cosine of that angle will not be 0. Okay?
Okay.
Are you convinced?
Yes.
You better be, okay? You can continue to look after class and let me know when you find another one. I'll be happy to share your good news. All right, so now we have identified the terminal. Once we have identified the terminals, how many angles will end up on these terminals? Measure the way we measure A. ARD, how is A defined? You can measure counterclockwise or clockwise, right? If you measure counterclockwise, you hit it first time, that's pi over 2. Yes?
Yes.
3 pi over 2. Right? Negative pi over 2. Negative 3 pi over 2. Could I keep this process going? Could I keep this process going? Yeah, right? So what are those angles? Let's write down those angles. What are those angles? What are those angles? Pi over 2, right? Plus minus pi over 2, right? Right? Plus
Yeah.
minus 3 pi over 2, right? You guys need to follow me doing this. You need this pattern recognition technique, pattern recognition practice for Calculus 2, chapter 11. Okay? And continue, what else do we got? Plus minus 5 pi over 2. What will be the next one if you keep on going? Seven pi over 2. And the list go on. So how can we describe the pattern? Is there a pattern? Is
Yes.
there a pattern? What
What-
pattern?
Would you write down k pi over 2? Would that be the correct form of writing it?
K pi over 2. So the same as sine. So if you think it's a k pi over 2, how would you test it? Test your conclusion. And of course, you need to specify k. What is your k?
K would be an integer.
K is an integer.
So it
K
would.
is integer, that means not only pi over 2 works. So your description is this, right? Give me your description. Give me k times what?
K times pi over 2.
K
And
times pi over 2.
No, not like that, not like that. You put k and pi together and then divide by 2.
This is the same thing.
Oh, okay. So yeah, that, and then where k is an integer.
Does it work? And the k is integer. Okay,
Mhm.
I want everybody to check if this answer works. Okay, this is called self-check. Okay, in calculus 2, you not only have to be able to identify patterns, you have to be able to check if you get it right. Chapter 11, right, Farouz? Very difficult chapter.
Yes, Professor.
Very difficult chapter. You learn sequence series. Well, my student had a hard time. Right? Does this pattern work? If you say integer, k is integer, when k equals to 2, does it work?
No, it doesn't work. Okay, I see what it
It
is.
doesn't work, right?
Okay, I see what it is.
So false once, false. But it's a good attempt. So keep trying. Right? So this option doesn't work. That's okay, no big deal. No big deal, we keep on trying, okay? So let me show you another pattern. Another way to look at this pattern, right? So I can see this as 1 times pi over 2. I'm gonna move the 3 to the front. So 3 times pi over 2. 5 times pi over 2. Right? They're all the same values, right?
Yeah.
7 times pi over 2. So what do we see? 1, 3, 5, 7, 9. What kind of numbers are there? Are these? What
Odd
kind of
number.
numbers are these?
They're odd.
They're all numbers. Could I say A will be the odd number multiples of pi over 2? Can I say that?
Yes, because it would work and it makes sense.
That's right. You can see, you know, you just be patient with yourself. Odd number multiple of pi over 2. It cannot be even number, right? That's where we had the problem, right? Now the question is, how do we describe odd number? I think we addressed this before, right? 2k plus 1. If you use 2k plus 1 for any k in any integer, 2k plus 1 is always going to be an odd number. So odd number multiples of pi over 2 would just be 2k plus 1 multiplied pi over 2. And I know this is a little, you know, challenging for most of us, especially if you see this for the first time. But, you know, your professors in calculus classes or your professors in 4-year colleges who teaches math, they want to see this. They want to see this. When they see this, they're happy. They don't see this, they're not happy. They're not happy, they don't give you points. That's period. No question asked. Because if you don't do it, someone else in the class will. That's a fact of life. Okay, so learn it. Learn it. You can do it. Now to ask yourself, can you do it? Are you doing it?
Yes.
Can you do it? Can you do it?
Yes. Yes, I can.
See? Give yourself a pat on the back. Right? Now it's not a big deal anymore, right? At the beginning it was hard, right? Now is it still hard? Not anymore. I hope that's true for everyone, right? Okay. That was work. That was a hard work, but I tell you, it's worth every second of your time. You're gonna get points. You're gonna get points. Okay. All right. So if output is 0, the input would be 2k plus 1 pi over 2. How do you verify? And you're gonna cover all of these. Can you verify you're gonna cover all of these numbers? You want to verify, right? Can you verify them? How about we do a breakout rooms? And for Roost, take some of you, and I will take some of you. We'll see how to verify. How to verify you got it right. Breakout rooms. Open all rooms. Okay, if you want to go with for Roost, we're going to probably do pretty much the same thing. So let's verify. Verify that this form is going to give us all of these numbers. Okay. All right. Anybody going there? There's no pressure of any sort. I think Farouz is already.
I'm here and I'm watching breakout room, Professor. If anybody goes there, I will go there too.
Okay, thank you. So to verify what you do, because k is integer, right? Because k is any integer. What does it mean k is integer? It means that k can be what? K can be 0, plus 1 minus 1, plus 2 minus 2, and so on and so forth, right? And the list go on and on and on forever. Okay, I trust you. You trust me. You don't have to do this forever. So when k equals 0, what happens? This form will give you what? K is 0. Okay, 2 times 0 is 0. 0 plus 1 is 1. So this will be pi over 2. Is pi over 2 on the list right here?
Yes.
Okay, so pi over 2 is covered. We want it to be covered just right. We cannot have pi in there, right? Right? We cannot have odd number of multiples of pi over 2. We must have, we must only have odd number multiples of pi over 2, okay? So how about k equals to 1? What happens to k equals to 1? You guys know how to verify, right? So I'm going to give you a couple numbers. I'll give you 5 minutes. And if you want to go to breakout room, and Farouz is there. Okay, so you're going to verify. You're going to get, you're going to get for each k value I've chosen here, you're going to plug in that formula and you're going to check the list to see if that quantity is on the list. I'm sorry, what did I do? Okay. 5 minutes. 5 minutes. Whether you work with me or work with Farouz, and we're gonna give you this time to do it. And Farouz might show your work, and you just do it now. Check. We're covering 5 classes in one. 5 classes in one, okay? These odd number, even number consecutive integer expressions first was introduced typically in elementary algebra. Okay, but unfortunately, you know, it might be forgotten or had never been seen or never been taught because we have come from, you know, from very different backgrounds. Huh, Farouz is still here.
Yes, Professor, nobody was there.
No problem, no problem. I think everybody's just busy checking that pattern.
And I wrote all those options in my board and matching your answers with your answer.
Thank you.
You're
So
welcome.
you can keep on going, really, but you will find that you always get odd number multiples. And I said this is verifying. And then, you know, when you work with patterns in Calc 2, you start see patterns in Calc 1 too, you know, chapter 5, when you divide the intervals. But in Calc 2 is even more demanding in chapter 11, which take a big chunk of your grades. That you always have to go through this process, right? You identify a pattern, you have to check your pattern. Does it work? Does it not? You have to make adjustment back and forth, right? Sometimes it works, sometimes it works first time, and sometimes it works after 10 attempts, right? That's all very common. Sometimes it takes you days, right? Sometimes it takes you days to figure that out. Well, at least that happened to me. Sometimes for one question in math, it could take you days and months. And some of the math questions, it hasn't been resolved for hundreds of years. Okay, and people, some of the mathematicians spend their lifetime just to conquer a math problem, and they may end up being, you know, not be able to do it at the end of their life. And then you would say, who is so nerdy to do that? Oh yeah, there are people, there are professors doing that, right?
I have one example for that, Professor.
Go ahead.
0 equals infinity.
0 what?
0 equals infinity.
0 equals infinity hasn't been proved or not proved?
Hasn't been proven.
Has not been proved.
It takes centuries. Mathematicians are working on it. I have seen a book with chapter 4 talks about that, but still not convincing me yet.
Well,
So
that's not a fact yet, right? It's a conjecture. It's called a conjecture.
That is true. Yeah, exactly what you
It's a
said.
conjecture, right?
That's it.
Conjecture.
Yeah.
It's unproved fact, unproved maybe fact.
That is the example for what you said. Many mathematicians work for some concept in math for the whole life, for their for their life, still haven't been proven.
That's right. There are some success stories. If you guys have learned the Fermat's last theorem, that was proved, during my lifetime by someone, but even that's not me. I think there's a professor in Cambridge, and Andrew Wiles. I'm not sure I get the name right, but you can look it up. Okay, Fermat's last theorem. Last theorem. Okay, you're actually going to learn Fermat's theorem. Okay, this is about Fermat's last theorem, but you're going to learn you're going to learn another Fermat's theorem in calculus 1. Okay, Fermat has many theorems, and one of the theorems will show up in your calculus 1. And his last theorem was proved only recently, but Fermat was a mathematician, lived, a couple hundred years ago. I don't know when he lived, actually, you can look it up, okay? All right, so now let's go back. Have we found the y-intercept, x-intercept, right? So the y-intercept for cosine is what? 0, 1. How about x-intercept? We have many x-intercepts, right? We have many x-intercepts. How many? Infinite. And how do we express them? Odd number multiples of pi over 2. Just as we speak it, okay? There's another form to express odd number. There's another form to express odd integer. The other form to express odd integer is 2k minus 1, okay? So you can use either 2k minus 1 or 2k plus 1. Which one is more popular? It really doesn't matter. Once you understand how it works, once you have done that verification, what did I do? I think I made a double. 2k plus 1. I made a double somewhere. 2k plus 1, comma 0. Okay, so those are the x-intercepts. All right? Any questions so far? Was that fun? Did you get it? Once you get it, you get it, right? Any questions?
No.
No,
All right.
thank you.
Good. I'm glad you guys paid attention. Oh, please do pay attention, okay? Because I can just sleep in and have you guys watch the recording. But instead, I personally insist on doing live lectures because I want to interact with you guys. Now, we have 4 other functions domain range to be discovered, right? And pictures and all of that stuff. So let's see from the definition, okay? We're still back to ARD. We're still digging. We're still digging into ARD to see what we can discover. Now for sine, cosine, we have discovered this much. Let's look at the domain. Domain for the other functions. What are the other functions? Tangent, cotangent, secant, cosecant. Okay. I taught about this in multiple ways, but this semester I'm going to try this way because I think this way might make it easier for you. Okay. From definition, what have we discovered? Tangent A equals to what? Y over X, right? Doesn't this also equals to Y over R divided by X over R? Yeah.
Yeah.
And doesn't this also equals to sine of A over cosine of A? So from definition, we know sine A equals sine A, a tangent A equals to sine A over cosine A, right? A lot of you already know that, but you know where it came from. It came from definition, right? If tangent equals to sine A over cosine A, what will be the domain for tangent? Could it still be all real numbers? It cannot be, right? Because some of the real number may cause cosine A equals 0, right? So to determine the domain, we have to make sure that cosine A, which is in the denominator, cannot be 0. That must be guaranteed. What is the opposite of not a 0? The opposite of not 0 is 0, right? When will cosine A be 0? When will cosine A be 0? We just talked about it, didn't we? Didn't we just talk about it? Didn't we just talk about that cosine? The x-intercept of a cosine, what is that? When input is 2 pi over, all number multiples of pi over 2, the output is 0. So these are the quantities. These are the quantities 2k plus 1, right? All number multiples of cosine A, of all number multiples of pi over 2, all number multiples of pi over 2, these A will cause cosine equals 0. So these input, if these input, give it to cosine A, is going to cause what? It's going to cause 0. Can we allow these in the domain of tangent? No, right? Because denominator cannot be 0. So A cannot be 2k plus 1 times pi over 2. So how do we read this? Okay, all real numbers except, that's how we read it. Do you guys follow me? That's a domain for tangent. Domain for tangent. That's pretty easy to identify, right? Because once you have identified the x-intercepts and x-intercept for sine and cosine, then you can identify the domain for tangent. So how about for cotangent? How about for cotangent? How about for cotangent? How about cotangent? Cotangent is x over y, right? Yes,
Yes.
it is also x over r over y over r, right? Therefore, it is sine of, it's a, oh, sorry. So it's a cosine of A divided by sine of A, right? So to determine the domain, sine A cannot be 0, right? Are you guys with me?
Yes.
And what will make the sine A equal 0? We just did it, didn't we? What value makes sine of A equal 0? What kind of A goes through sine function will produce 0? We just did it, right? The x-intercept, right? Right?
Yeah. So
A pi. Therefore, when A equals to multiples of pi, any multiple of pi, because k is any integer, right? K is any integer. Any multiple of pi will cause sine produce 0 output. Therefore, if sine A cannot be 0, A cannot be what? Cannot be k pi, where k is an integer. Does that sound logical to you? So the domain for cotangent would be what? All real numbers except what?
k pi where k is integer.
That's right. All real numbers except what? K pi. Let's keep on going. Let's keep on going. Right? So from the definition, what else can we dig out? Cosecant and secant, what their relationship with sine, cosine? Do you guys know? Cosecant of A equals to what? Equals to R over X. I'm sorry, R over Y, R over Y. Isn't this 1 over sine? Right? Yeah. Is that 1 over sine, right? Yes?
Yes.
So when we determine the domain, when we determine the domain, sine A cannot be 0, right? Yes? So what number will cause sine A equals 0? Right here, right? Therefore, A cannot be what?
K pi?
That's right. Great job. You got it. How about secant, right? All real numbers except k pi for cosecant. How about secant? You know, these functions, even though they're less commonly used, but they're still used. Secant and cosecant, even though they're less commonly used, they're still used. Tangent, cotangent, you need to know them. You need to know them. In Calc 1, in Calc 2. They're still used. So secant is x over r. I'm sorry, is r over x, okay? R over x. So this is 1 over cosine, right? So what would be the domain? To determine the domain, cosine A cannot be 0, right? Are you guys with me? And what will cause cosine A equals 0? We're here again, aren't we? Yeah? Yes?
Yes.
Can you put together a summary here for the domain of all of these functions? So far, we have most thorough studies about sine, cosine, for which we did the curve, and of course, we're going to continue to do some curve. We're going to do a curve for tangent. Okay. We may not do curve for cotangent, but we probably would not do the curve for secant, cosecant because we may not have enough time. But we definitely could do the domain, right? You can do the domain. So let's put together the summary for domain for today. Okay, the summary, the domain summary. Okay, of all these functions. Whoops, my bad. Right? So now, we also want to build in some logic into this table, right? So for sine, cosine, what's their domain? All real numbers, right? No problem. Okay. We even know their range. What's their range?
Range for sine of A is -1 greater than less than sine of x greater than 1.
Wonderful. Okay, so this is the form I want you guys to carve in your brain. Okay, we're not going to take everything from sine, cosine, but we're going to take some useful things. Okay, we're going to take some useful things. For example, x-intercept. What's the x-intercept for sine? K pi, right? Comma 0, right? For cosine, what is it? 2k plus 1 pi over 2 comma 0, right? So now let's look at tangent. What's the domain for tangent? Tangent is sine over cosine, right? Right? Cosine cannot be 0. What will make cosine 0? So A can be any real number but whatever makes cosine equals to 0, right? Do you hear that? Do you hear that logic? Because once you understand that logic, do you have to memorize much? You don't have to memorize these things, do you? I never have to memorize these things. Okay.
So now we learned that it's easier to drive it than thinking about memorizing it. Memorizing it almost becomes impossible.
Yeah. To memorize it, we cannot trust our memory, but we can trust our logic, right? Cosine A over sine A.
Yes, and since there is more than one formula, we are gonna always confuse one from other. Which one was what?
That's
Domain,
right.
range, this and that.
That's right. You really have to do it. As I told you, I'm not a very smart woman. I have to do everything. I have to go make sure, everything is being thought of. Okay. It takes someone 1 hour. It will take me 10 hours. Okay.
But when we learn it for the rest of our academic life.
That's right. So once I get it, I never have to memorize it. Okay. Once you figure out by yourself, no one can steal it from you.
And you
Okay,
can teach it.
It's
and
going to
you
be
can,
yours.
yeah.
Yeah.
And you can teach it to others.
Yeah,
all
but
the time.
that's optional. Not everybody wants to do that, right? So this is a K pi. Do you see how naturally it comes, right? Do you guys understand? You just had to understand what's input, what's output. In what case input is 0, in what case input is 0, in what case output is 0. You only have input output to deal with. Do you guys follow me? Now let's look at secant, right? Cosecant. Secant A equals what? 1 over cosine. And they have the same domain. How about cosecant? Is equals to 1 over sine. We haven't done the range. You see, we still have much to do. We still have much to do. So far, so good. Do you see that logical connections? Before we go further, okay, we have 7 minutes left. We have 7 minutes left. I like to bring out another thing that's also can be derived from the definition, right? So we're still digging deep in the definition. In the definition, there's another, right? From definition, from ARD, we have this R equals to root x squared plus y squared. Right? We know that's from Pythagorean theorem, right? Then if we square both sides, what do we get? We get R squared. Everybody should roll up your sleeve and do this on your paper, please. Don't just watch, okay? You can't learn math by watching. You have to do it. I'm typing it. Why do I insist on typing it? I actually have tools I can handwrite. I have a machine there, but why don't I use it? It would make my life a little bit easier. The reason I insist on typing because I don't want my handwritings to confuse any one of you. Typing make it clearer. Okay, that's why I insist on typing. Okay, So now because R is not 0, sorry. Okay, because R is not 0, right? We know R is not 0, right? The way R is selected, R is not 0. So what we can do, right? What we can do, we're going to divide R squared on both sides. Divide R squared on both sides. Everybody must do this, okay? Divide R squared on both sides. So Y squared divide by R squared. Because this is 5 classes in one, you have to get your hands dirty. Otherwise, you won't be able to do 5 classes in one. Okay, R squared divided by R squared equals what? Equals to 1. And the X squared over R squared is what? It's X over R squared. And what else? Y over R squared. Okay, what is X over R? What's in the definition about X over R? What's in definition about Y over R? X over R is cosine, right? Yes, cosine of any angle. And this one is what? It's a sine of any angle. So this is a famous identity, which is derived also from the definition. Okay, that is sine squared of any angle plus cosine squared of any angle. In most of the application, they use X replaces A. It doesn't make any difference. Okay, and these A are from the domain of sine cosine. Okay, this is the famous identity. This quantity equals to 1. And from this quantity equals to 1, you can derive a lot more stuff. You can derive a lot more stuff. So you guys can start deriving. Okay, you guys can start deriving. So let me show you another one, right? If you continue from here, right, you can get the following. You take this guy, okay? I think you guys need to commit yourself to how to learn how to derive, okay? You're gonna divide by cosine square of A. You're going to divide by the same quantity on every piece, provided that quantity is not 0, right? Cosine A is not 0. And what would this be? This will give you tangent A. Plus 1 equals to, what is this? Secant squared. If you didn't take trigonometry, you should derive everything I have in the notes. Otherwise, you're going to have a hard time. Okay, because in this class, we won't have time to derive a lot of things. People who have taken trigonometry, they have some deriving experience. People who never had a trigonometry, you have not derived those trig identities, then you're going to have some hard time, because you need those, you need some of those identities. And we're going to touch some identities for sure, but it's not enough. You're going to need a lot of trig identities in Calc 1 and Calc 2. Okay.
Professor,
So yes. Oh, what did you say?
Sorry, interrupting.
okay.
Just want to let a student know also, I'm in Math Study Center Wednesdays and Thursdays from 3 to 6. Yesterday I was there and a couple of your students showed up and they benefited from refreshing their trigonometry concept.
Wonderful, wonderful. Today I will be assigning you some deriving, and you'll be quizzed on domains and stuff. And I will see you guys tomorrow. Okay, keep on deriving. Okay, you will get a deriving assignment. You get a deriving assignment.
Thank you,
Okay?
Professor.
Thank you, guys.
Thank you, Professor.
Please ask questions. Okay. Have a great day.
Wait, I have one quick question.
Yes, Jake.
It's regarding the homework.
Sure.